Greetings everyone. Let's start with today's topic, operating system, second lecture. Let's see the topics we will cover under this section. The first one is OS operations and the second one is managing processes. So let's jump on to the first topic, that is OS operations. The first one is interrupt driven by hardware. In this, the software error or request creates exceptions or trap by division of zero, request for operation system service. Other processes problems include infinite loop, processes modifying each other or the operating system. The next one is dual mode operation, which allows OS to protect itself and other system components. It's of two types, which is a user mode and a kernel mode. The second one is mode bit provided by hardware. It provides ability to distinguish when system is running user code or kernel code. Some instruction designated as privileged only executable in kernel mode. And the third point here is system call changes mode to kernel returning from call resets it to the user. Now let us talk about the multiprogramming needed for efficiency. In this, a single user cannot keep CPU and I/O devices busy at all times. The multiprogramming analyzes and organizes jobs so CPU always has one to execute. A subset of total jobs in system is kept in the memory. One job selected and run via job scheduling. When it has to wait, OS switches to another job. Now we'll talk about time sharing. Now we'll be talking about time sharing, which is also known as multitasking. It is a logical extension in which CPU switches jobs so frequently that users can interact with job while it is running, creating interactive computing. The first one here we'll talk about is the response time, which should be less than 1 second. The second thing is each user has at least one program executing in memory, which is known as process. The third thing here is if several jobs are ready to run at the same time, CPU scheduling must be done. The fourth point here is if processes don't fit in the memory, swapping moves them in and out to run. The fifth point here is virtual memory allows execution of processes not completely in memory. Coming to the next topic, which is process management. Process management, as we define it, is a process, is a program in execution. It is a unit of work within the system. Program is a passive entity. Process is an active entity. Now, process needs resources to accomplish its tasks, which is first one, CPU, memory, input, output, and files. The second thing here needed is initializing of data. Process termination requires reclaim of any reusable resource. Single-threaded process has one program counter specifying location of next instruction to execute. Processes execute instructions sequentially, one at a time until completion. Multi-thread processes has one program counter per thread. Typically, system has many processes, some users, some operation system running concurrently on one or more CPUs. Concurrency by multiplexing the CPUs among the processes or threads. Now the process management activities. These are the operating system is responsible for the following activities in connection with process management, which are creating and deleting both user and system processes, suspending and resuming processes, providing mechanism for process synchronization, providing mechanism for process communication, providing mechanism for deadlock handling. Thank you.